I am Anil Kumar. Welcome to my series on partial fractions. Here is exam practice question for you. We are given the function f of x equals to 4x squared plus 25x minus 3 divided by three linear factors x plus 1, x minus 2, and x plus 5. As you know, this rational expression can be written as a divided by the first linear factor plus b divided by the second and c divided by the third linear factor, which is x plus 5. Now the question here is part A. Find the value of the constants a, b, and c if x is greater than 2. Part B is explain why the method of substitution could not be applied in solving this equation. All right, so most of the time you're solving such equations using the method of substitution. But in this particular case, you cannot apply that method. You need to provide reason for that. And part C gives you a hint. It says use the method of substitution to verify your result if x plus 2 is not a constraint. So clearly, x plus 2, x greater than 2, is a constraint which is not letting you apply the method of substitution, correct? So how do you explain that? Well, clearly, to solve it by substitution, since the denominators are x plus 1, x minus 2, and x plus 3, the values which we have to substitute are what? We have to substitute x equals to minus 1, x equals to 2, and x equals to minus 5. So clearly, now these values are all less than x equals to 2, right? So they're all less than 2. So therefore, we cannot substitute these values and find the answer. So I hope the concept is clear to you. So in this particular case, we need to compare the coefficients, right? So we'll take common denominator, then both the equations on the left side and the right side, the expressions, will have the same denominators, and we'll compare the coefficients. We'll get three equations since it is a quadratic equation on the top, and we'll try to solve for three unknowns, a, b, and c. So let us see how to do it now. So we are given this particular equation with the restriction that x is greater than 2. So you cannot use any value of x which is less than equal to 2, correct? Okay. So let's expand this. We have on the left side 4x squared plus 25x minus 3 over x plus 1 times x minus 2 times x plus 5. And on the right side, we could take this common denominator, which will be x plus 1 times x minus 2 times x plus 5. So if you do so, a gets multiplied by the factors x minus 2 and x plus 5 plus b times x plus 1 times x plus 5 plus c times x plus 1 times x minus 2. Correct? So that is how it is going to be. Let us now, so what we can do, since the denominators, we have the same factors, correct? We could actually cancel them. So we can now compare the coefficients, correct? So let us expand the numerator part. So if you do that, we get what? A times x is x squared. Then 5 minus 2 is 3. So I'm actually cutting down on one step. You could add more steps to it. Minus 10. Ultimately, you will get this by expanding the product of these binomials. As far as the second term is concerned, b times x squared, 6x, 5 plus 5 times 1 is 5 plus plus c times x square. Minus 2 plus 1 is minus x, and minus 2 times 1 is minus 2. So that is what you get on the right side, and on the left side you have 4x squared plus 25x minus 3. So you could actually collect the like terms, x squared being common factor, you get a plus b plus c. Now with x you get 3a, and here you get plus 6b minus c, and the constant terms which are minus 10a, 5b, and minus 2c. So that gives you three different equations, right? So let's write down these three equations. First one is comparing the coefficients. We have got 4 equals to a plus b plus c. And then we have 25 equals to 3a plus 6b minus c. And the constant minus 3 is equal to minus 10a plus 5b minus 2c. Now to solve these equations, we can always, uh, let's give them our equation numbers. So let's say this is our equation number 1, this is equation number 2, and that is equation number 3. So easily we can eliminate c from first and second, but to eliminate from the third, we can actually also create another equation number 4. We'll multiply this equation by 2, so we get 8 equals to 2a plus 2b plus 2c. Now with that, we could eliminate c, correct? So we have this set of equations to work with, and we can actually work with these equations and solve. So let me copy these equations, which is in itself a difficult process, since I'm going to do it on a separate page. Anyway, what I can do here is simplify some of it. Okay, let's do it on a fresh page. So first one here is 4 equals to a plus b plus c. And from here, we're doubling this up and writing this as 2a plus 2a, right? Plus 2b plus 2c. The second equation is 25 equals to 3a plus 6b minus c. 3a plus 6b minus c. And the third equation is minus 3 is minus 10a plus 5b minus 2c. So minus 3 equals to minus 10a plus 5b minus 2c, right? So these are the equations for us. So let's number these equations as we did earlier. 1, 2, it becomes easier to communicate. We got 4. We got this 4 by multiplying 1 by 2, correct? That's how we got it. Now, we should eliminate by adding equation 1 with equation 2, the value of c. So when you add them up, what do you get? 4 plus 25 is 29, which is equal to 4a and 7b. So you get that. Now, equation number 4, which has got plus 2c, and equation number 3, which is minus 2c. When you add them up, you get 8 minus 5, which is 8 minus 3, which is 5, and minus 8a, and 2b and 5b, you're adding them up, you get 7b. Well, that's good. So we get these two equations. We can number these equations. It's a process of elimination, right? So we'll call this as 5 and 6. Now anyway, we can do equation 5 minus 6. Now let's do equation 5 minus equation 6. Correct. And then what do we get? So when you take away, you get 24 here equals to 12a. And that gives you the value of a as equal to 24 over 12, which is 2. Correct? So we got the value of A. Now we can find the value of B straight from one of our equations. So let's use this value, A equals to 2, in one of our equations. So let it be this equation. Correct? We'll substitute here. So when you substitute in this equation, you get 29 equals to 4 times 2 plus 7b. So 29 minus 8 is 7b, which is 21 equals to 7b. And clearly, we get b equals to 21 over 7, which is 3. So we get the value of b as 3. Right? Now, we need to find the value of c. We could use our equation number 1, which is 4 equals to a plus b plus c. Substituting the value of a as 2 and b as 3, we get 4 equals to that. So c is equals to 4 minus 5, which is minus 1. So we get the value of c as minus 1. And the answer, therefore, is that a is equal to 2, b is equal to 3, and c is equal to minus 1. Clear? So by elimination, we could actually solve these equations and get our solution. Perfect. So that was by comparing the coefficients, right? So we compared these coefficients and got our equations 1, 2, and 3, and we solved it. Perfect. That was our first method to do. Now, the question was, let's get back to the question. So we've done part 1. Explain why we've done that. Now, the part C is use the method of substitution to verify your answer if x greater than 2 is not the restriction. So basically, we now need to do with the second method also. So now the restriction has been removed, and therefore we can actually do the substitution method, right? So we can actually rewrite this equation as 4x squared plus 25x minus 3 as equal to, so let's multiply again, write the same equation, a times x minus 2 times x plus 5 plus b times x plus 1 times x plus 5 plus c times x plus 1 times x minus 2. Okay? So we got this. Now, substituting, now we can substitute the values, right? So if I substitute a value of x equals to minus 1, then what happens? See, so if I write x equals to minus 1, then the left side becomes 4 times 1, and that is minus 25, and this is minus 3 equals to. Those two terms become 0, and we get a times minus 3, and minus 1 will give me 4. So we can find the value of a directly, correct? So we got 4 minus 25 minus 3. So we get 24 here, right, with a negative sign. And on this side, we get minus 12a. So clearly, the value of a is minus 24 over minus 12, which is indeed equals to 2. So it is exactly the same answer which we got last time, correct? So that is with x equals to minus 1. And now to get the value of b, these two factors can be 0 by substituting x equals to 2. So let's substitute x equals to 2 now, use a different ing. So if I have x equals to 2, let's say, in that case, what do we have on the left side? So left side will be 4, 2 square is 4, so we get 16, right? 4 times 4. 2 times 25 is 50, and minus 3 equals 2. Substituting 2, those values will be 0, right? So b times 2 plus 1 is 3, and 2 plus 5 is 7. So that is 21b. And here what do we get? So in this particular case, we get 3 less than 16 is 13. So 13 if you add to 50, so So we get 63. So 63 over 21 is the B value, which indeed is 3. Correct? So we get the value of B as plus 3. So that is what we got earlier also. Now the third value, you can get the value of C provided you substitute a value of minus 5. So if I substitute x equals to minus 5, 5 squared is 25. So in that case, 25 times 4 is 100. 5 times minus 5 will make it negative, yes. 5 times 5 is 25, 2, 10, 125. And here we have minus 3 equals 2. So these two terms, when you substitute minus 5, will be 0, right? But here we have C times minus 4 times minus 7. Correct? So that is what you get. So when you calculate, this gives you the value plus 28, 7 times 4. And on this side, we have the value of minus 25 and minus 28. Right? So minus 28, C. And that gives you C as equal to minus 1. So we got exactly the same answer which we got last time, which is equal to A is equal to 2, B is equal to 3, and C is equal to minus 1. Is that clear to you? So using the method of substitution, we got the same answer as we had got earlier, as you can see here, right? So both the methods actually give you the same answer. However, the important thing in the test paper is that if they specify that x is greater than 2, in that case, you have to apply the method of comparing the coefficients since you cannot do substitution. And that is the learning from this particular example. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.